Welcome back to episode 2. Before we can build intelligent machine learning models, we need to understand how computers actually perceive the world around them. Unlike humans, computers don't see images, hear sounds, or read text. They only understand numbers. To translate the real world into numbers, AI relies on a branch of mathematics called linear algebra. At the most foundational level of linear algebra, we have a scalar. A scalar is simply a single number. It represents a magnitude, but it has no dimensions or direction. In the real world, a scalar could represent a single data point, such as today's temperature, a person's age, or the price of a house. But a single number usually isn't enough to make complex decisions. If we group multiple scalars together into a single column or row, we create what is known as a vector. A vector is a one-dimensional array of numbers. Think of it as a comprehensive list of features describing a single object. For example, if we want an AI to predict house prices, a vector could represent a single house. The first number is the bedrooms, the second is bathrooms, the third is the age, and the fourth is distance to the city center. Taking it a step further, if we stack multiple vectors side by side, we create a matrix. A matrix is a two-dimensional grid of numbers organized into rows and columns. Matrices are incredibly important in AI, especially for computer vision. To a computer, a black and white photograph is not a picture. It is simply a large matrix where every single number represents the brightness of a specific pixel, from black to white. But what if we have a color image? Color images have red, green, and blue channels. To represent this, we stack multiple matrices together, creating a 3D structure. In mathematics, we call this generalized structure a tensor. A scalar is a zero-dimensional tensor. A vector is a 1D tensor. A matrix is a 2D tensor. When we go to 3 dimensions or higher, we just call them tensors. This is where tools like Google's TensorFlow get their name. To recap, AI translates the real world into numbers using tensors of various dimensions. Scalars represent single values, vectors represent feature lists, matrices represent 2D data like grayscale images, and higher dimensional tensors represent complex data like color images or video. Understanding this structure is essential because all of machine learning is simply mathematical operations performed on these tensors. Great job, and see you in the next lesson.